Let's imagine that we have two separate teams of engineers working on the same application. And this application is just a video player. And the application is going to be separated into two components. So here we're going to have the client code, and here we'll just have our framework code. So team 1 is responsible for the framework code, and team 2 is responsible for the client code. And the application is a video player. Specifically, they're working on the part that renders the window, the timeline, and the play button for the video player. And this is the video player. Now, the client code is going to be responsible for actually rendering these objects. And the framework is where these objects are going to be defined. So the objects that we're going to need to be able to create in the client code are the play button, the timeline, and the window. So what team 1 is going to do, since team 1 is responsible for these objects, and let's go ahead and make this a little bit smaller. So team 1 is responsible for providing these objects to the client code for team 2. So team 1 is going to create what we call a factory, and it's going to be an abstract factory, and we'll call it player component factory, and it's going to be a class. So what does this actually mean? What's an abstract player component factory? So since this class is abstract, it's basically just going to be the interface that the client code's going to use to produce these objects. So it's just going to define the methods for creating these objects, but it's not going to implement those methods. We're going to derive two other classes from this abstract class to implement the methods that will create these objects. So let me show you what I mean. So this abstract player component factory class is going to define a method called createComponent. And this method should return type component. Now, all of these components, the play button component, the timeline component, and the window component, their classes are all going to be derived from this component class. So component's also going to be an abstract class. It won't be a factory, it'll just be an abstract class component. So remember, this is still team 1. Team 1's going to create this interface that the client code's going to use, but we're not at the client code part yet. So team 1's also going to create this component class. And we're not going to think about any of the methods on this class or anything yet. This is just the component class, which the classes for these objects extend. So the play button class extends the component class, the timeline class extends the component class, and the window class extends the component class. So just keep that in your imagination. Now, this abstract player component factory class, remember, it's just the interface. So we need to define the concrete classes that will implement the interface provided here. So this video player is going to be able to be used on multiple platforms. So it's going to be available on both Windows and Mac OS. So from this abstract class, we'll derive two classes. So we'll have Windows Player Component Factory, and we'll have Mac Player Component Factory. And both of these subclasses, these are subclasses of this abstract Player Component Factory class. And both of these subclasses, they have to implement this createComponent method. And actually this createComponent method, I forgot to add a parameter. It should have a parameter, which is type. And that's just going to be the type of component that we want to create. Do we want to create a play button, a timeline, or a window? And the factories here are what are going to produce these objects. Because remember, createComponent has to return a component, and these objects here are subclasses of this component class. So actually, we're going to have classes for Windows play button, Mac play button, Windows timeline, Mac timeline, Windows window, Mac window. So just to be clear, there would be a total of 6 classes here, and all of them are going to be subclasses of component. So sorry this is sloppy because I'm running out of space here, but basically when we do createComponent for Windows, it's going to take in a type, and if the type is play button, it's going to return a new Windows play button. It's going to return the play button object. And if type is timeline, it's going to return a new Windows timeline. And if type is window, it's going to return a new Windows window. Now that is the implementation of this abstract factory for Windows. So let me make this smaller because I need space to do Mac. So the Mac factory is going to do the same thing, but it's just going to return Mac components. So as you can see here, the create component for the Mac factory is going to return a new Mac play button if the type is button, and it's going to return a new Mac timeline if the type is timeline, and it's going to return a new Mac window if the type is window. Now remember, all of this is still Team 1's code. So we see that we have this Mac player component factory and this Windows player component factory as well. Now this create component, these methods, these are factory methods. So a factory method is going to create the object. So we have this Mac player component factory. The factory method creates the component, the Mac player component. So the same thing applies to like a real world situation. If we had a car factory, the car factory is going to create car objects, right? The same here, we have this Mac player component factory. This factory method create component is going to create the object associated with this factory. Now we have to get through the rest of this to understand why this is useful, so just stick with me. So like I said, this application is going to be cross-platform. So depending on which platform this application is running on, the client code is going to be working with a different factory. But the client code isn't going to need to care about which concrete class that it gets. The client code's only going to know about this abstract player component factory class. So if we zoom in here to the client code's simply going to receive a factory. And with that factory, the client code will simply be able to do this. So as you can see, the client code, when they want to render the play button, they're just going to need to declare this play button of type component, and they're just going to need to call factory.createComponent, and they're only going to need to provide the type of component, play button, timeline, or window. The client code doesn't need to take into consideration if they're running on Windows or Mac or any of that. And that's because when this application is started, the framework is going to check the operating system, and then it's going to inject the proper concrete class. So let me zoom this out a bit. So when the application starts, the framework's going to check the OS, and depending on the OS, it's either going to inject this Mac player component factory or the Windows player component factory. But from the client perspective, they're just interacting with this abstract player component factory interface. And remember, each of these factories has the create component method, which is the factory method. Now, this is beneficial for a couple of reasons. We're localizing the knowledge of which subclass to delegate to the client code. So the team that's working on the framework layer of this application, their code has an understanding of which subclass to delegate to the client code. But the client code doesn't need to care or know about any of those implementation details. So they're both completely decoupled from one another. And to prove that, if we were to want to extend the player components to have additional components, so if we were to add the ability to use type equal to font, and we'd return a Mac font object or a Windows font object in that case, this addition isn't going to impact the client code. If the client code wanted to make use of this object, of course they could add that into the code. But if the client code doesn't need to make use of these additions, then the client code can just remain the same. It doesn't need to change at all. And also, if we were to change the play button that gets returned, for example. So like, what if we wanted to create a new object for this play button? We could change this and it wouldn't impact the client code either. So if we change this to another class that extends this component class, the client code still wouldn't need to be changed. They're completely decoupled. So as you can see, this class here, its subclasses are responsible for specifying the objects of type component that get created. From the perspective of this abstract class, which is the interface that the client code is interfacing with, it just knows that it's returning a component. It allows the concrete subclasses that extend this class to specify the objects that get created. And it's for the reasons that I just showed you, the decoupling. And another reason this is good is still part of the example that I just gave you. So remember, the client code doesn't know what operating system it's running on, and it doesn't need to know that. So since the client code doesn't know which operating system it's running on, it can't anticipate the type of component it needs. It can't anticipate that it needs a Windows play button because it doesn't know if it's running on Windows or Mac. So since the client code can't anticipate the class of objects it needs to create, the use of this pattern is imperative, because without the use of this pattern, without this decoupling, the client code would somehow have to figure out if it's running on Windows or Mac, etc. But in this case, the framework just determines which OS this code is running on, and from there, it can determine which factory the client code receives. Now, I know this kind of seems like overkill just for explaining what this create component method is, the factory method is. But you kind of have to understand all of this to understand the factory method, because the factory method is really just a part of this overall factory pattern. And actually, in this example, we made use of the abstract factory pattern as well. So this create component that's on these subclasses, that's the factory method. So that's the factory method pattern. Now this abstract factory, where the client code only interacts with this interface but doesn't know about the underlying implementation details of the subclasses, that's the abstract factory pattern. So this example actually contains both the abstract factory pattern and the factory method pattern. And you'll often hear people refer to all three of these like in the same breath, and it gets confusing because then you're like, wait, what's the difference between the factory pattern, the factory method pattern, and the abstract factory pattern? And actually, I'm showing you all three of them here. So abstracting away the implementation details of the actual factory from the client code here, that's the abstract factory pattern. The actual factory method that produces or creates the objects, that's the factory method pattern. And in my opinion, when people say factory pattern, it's not very specific. I just think of that as the actual factory that has the factory method. So you're using factories, but factories must have the factory method. So the factory pattern is just a generalized way of referring to the factory method pattern and or the abstract factory pattern. And I actually have a full video on the abstract factory pattern, so I suggest watching both this video and that video to give you an overall understanding of all of this factory stuff. But yeah, this create component method, these are the factory methods, and that is the factory method pattern. So let's get into writing some code so that we can solidify your understanding of this explanation. So to start, we're going to pretend that we are team 1. So we're the team that's writing out the framework code. And we're going to start with the component class. And this ABC here is just allowing us to create this abstract base class. So this is the abstract class for the component, and we're going to have an abstract method. And every component is going to have a render method. And this render method is just going to return a string. And since this is the abstract method, we're just going to pass here. We're not going to implement this method in this abstract class. So remember, ABC just means that this is an abstract class, and we actually need to import both ABC and abstract method. And we'll also import platform, and I'll get to while we're importing that later. And actually, if we just hover over this ABC here, you can see that it's a helper class that provides a standard way to create an ABC using inheritance. And ABC just stands for abstract base class. So this is just basically a template class, and all of the classes that extend this class should implement this abstract method. So we can now move on to creating all of the classes that will extend the component class. So right now we're creating all of the objects that need to be rendered for both Windows and Mac. So we'll start with Windows, and I'll just format. Now, as you can see here, this Windows play button, it's extending this component class. Therefore, it needs to implement this render method, which it's doing. And for rendering, we're just going to return this string render whatever item that we're rendering. So you're just going to have to use your imagination for that part. But essentially, we're going to do this same thing for every other component. So now we have all of the Windows components, and they all implement the render method. So now we're going to do the same thing for the Mac components. So we can just copy the Windows ones and change it to Mac. And these will be our Mac components. So these are the objects. All of these components are the objects that are being created by the factory method. So as I showed you in the explanation, the client code is going to be able to pass in a parameter to the actual factory method, and the factory method is going to spit out whatever component is associated with the parameter that's passed in. And again, the client code's not going to need to know what operating system we're on, and you're going to see why in a second. So now that we've created all of the components, we need to create the actual abstract factory. Now remember, the abstract factory is going to be the interface that the client code is going to use to produce the objects. So here is our abstract component factory. And remember, it's just going to define the method. It's not going to implement the method, but it's defining the method that needs to be implemented, which is the factory method. So it's defining this create component method. And remember, that method's going to take in a component type, which is just going to be a string, and it's going to return a component object. So this is basically the interface that's visible to the client code. The client code is going to be able to call this create component with a parameter called component type, which is a string, and the client code is going to expect a component object. So now we can create the concrete classes that extend this abstract factory. And we're starting here with the Windows Player Component Factory. And here is the method signature for the factory method that we need to implement. So we can go ahead and go down here and do the actual implementation. Now remember, the implementation is going to check the component type and return a corresponding object. So for example, if the component type is the string play button, we're going to return a Windows play button in the case of the Windows Player Component Factory. So this is where we're instantiating the object. The object gets instantiated inside of the factory method. And this is important because it means that the client code doesn't need to know the classes or instantiate these classes itself, which means that if we wanted to change something about any of these classes, or we wanted to change the types of classes that get returned, we wouldn't need to change anything in the client code. But if the client code were to be aware of and directly interact with and instantiate these classes, whenever we made changes to these classes, or whenever we wanted to swap out these classes for other classes, we'd need to actually update the client code as well. For example, right now, if we wanted to, since the client code only knows about this method signature here, it doesn't know these implementation details here. So if we wanted to, we could create a new class called Linux Play Button, and we could return that to the client, and it wouldn't impact the client at all. But if the client were instantiating that Windows Play Button on its own, and we were to want to replace the Windows one with the Linux one, the client code would have to go and replace that instantiation as well, if that makes sense. So let's change this back to Windows Play Button. So if component type is timeline, we're going to return a Windows timeline in the case of the Windows Player Component Factory, and the same for if type is Windows, we'll return a Windows window. So that's the concrete class for the Windows factory. So we're just going to copy this and do the same thing for Mac. So now we have the factory for Mac as well. Now at this point, we're going to write the code that detects the operating system that the program's running on, and therefore passes the appropriate factory instance to the client code. Now this here is just the entry point to the application. You can just think of it like the main function of any other programming language. So when the program is run, the code here is going to be run. And we're going to set the current OS equal to platform.system. And this is going to tell us what the current OS is. So as you can see here, it returns the system OS name, e.g. Linux, Windows, or Java. And in the case of Mac, it's going to return Darwin. So now we can just check if current OS equal to, and if it's equal to Windows, we'll pass to the client code a new Windows Player Component Factory instance. And we haven't created this client part yet because we're still acting as Team 1 who's developing the framework. So we'll get to this client part in a second. If current OS is Darwin, we're going to pass the client the Mac Player Component Factory instance. Else, we're just going to print OS not supported. Now that's going to be it for Team 1's code. So the framework code is done. And for the sake of example, I'm going to write the client code in this file as well, but just understand that when we're writing the client code, we're now acting as Team 2. So first, let me just create a function in here called client. And then this is just going to emulate the client. But don't take this structure too seriously. I'm just trying to show you the separation of concerns, the separation of the teams. And the client's going to receive a factory via injection or dependency injection. And that factory is going to be of type abstract player component factory. And this is just going to be void. So it's going to return none. And let's just pass for now. So we're not writing the client code yet. We're still not writing Team 2's code. Now, there's a couple of things that you need to take note of here. So the first thing that you should take note of is that the client's going to receive a factory, right? And that factory is going to be type abstract player component factory. So the client code's just interfacing with the abstract factory. And this part here is actually the abstract factory pattern, but I don't want you to get too confused about that. If you're interested in learning more about the abstract factory pattern, I have another video on that you can go and watch. But for the sake of understanding the factory method pattern, you just need to understand this. So the client code's receiving this abstract player component factory, but it doesn't know which concrete class that it's receiving. It doesn't know if it's receiving Windows or Mac player component factory, and it doesn't need to know. It doesn't care, because the responsibility of the client code is just to render the video player. Regardless of what operating system it's on, it's going to render the video player. So we could just actually create all of the objects that we need to render the video player. So we can just start with window, and we'll set that equal to factory dot. Now here's where we're using the factory method. Create component is the factory method. So if we use this create component right here, in order to create this window object, we're using a factory method, create component. So that's the factory method pattern. And we're just going to pass in the name window for the type. And we'll do the same thing for timeline. We'll do factory dot, and we'll use the factory method, and we're just going to pass in timeline for the type. And actually, let's just go up here and return none just in case the wrong type gets put in. And now we can go back down here and do play button and set that equal to factory and use the factory method and put in play button. And I forgot to mention, we're writing the client code now. Like, creating these objects here using the factory method is the client code. We're acting as team 2 right now. And team 2 is responsible for composing all of the objects together and rendering the video player. So first, team 2 is going to instantiate all of these objects using the factory method. And then we're just going to render each object. And you can just imagine that renders the video player to the user's screen. And yeah, of course, you're just going to have to use your imagination for that part, because the focus is the actual pattern. So that's basically going to conclude the writing of the client code. So team 2 wrote the client code here. This is the client code. Now, one more time, I want to demonstrate the actual benefits of using this pattern. And remember, we're using the abstract factory pattern as well as the factory method pattern. And it's common for both the abstract factory pattern and the factory method pattern to be used together. So as long as you understand the difference between the two, as I explained, then you should have a good understanding of all of this factory stuff. So the client code is here. So to demonstrate the actual decoupling, what if we wanted to make the Windows player component factory return a new version of the play button? So what if we created a class called Windows play button v2? If this class were here and we just updated this return with the new class, the client code wouldn't need to change anything. So if the application were running on Windows and it actually tried to receive the play button the same way that it is right now, it would just receive the version 2 play button. It wouldn't have to change anything because it's completely decoupled, as you can see. So I hope that with this explanation, you're able to understand some of the benefits of using the factory method pattern. We can localize the implementation details of these actual factories. We can allow for subclasses, the concrete subclasses, to handle the implementation details of the factory method. And most importantly, it provides decoupling, and it allows us to make our code more modular. So that's going to be it for the factory method pattern. I hope that you were able to learn something from this. And if you liked the video, go ahead and leave a like, and I'll see you in the next one.